So hello there. Hello. Bigger. Are you enjoying the conference? Yes. More. Are you enjoying the conference? Yes. There you are. That's better than an English crowd, and it's certainly better than the guys in Norway do. Checking that you're here for the right talk. It's obviously, this is not the async you are looking for, and that's what we're dealing with. So this kind of I've given async talks before, but this is a kind of, I keep getting asked really similar questions in people who can't be bothered going to Stack Overflow and seeing that John Skeets answered it already, who sat just there. So if I get anything wrong, he can correct me, or Joe can correct me, who's doing a talk on advanced async in the next slot. So yeah, and they keep asking me questions or doing silly things and taking a server out of action by using async await incorrectly. So this is where this talk really came from. So who am I to talk about this? That's my Lego minifig given to me by Betsa Webby from TechSmith, which is quite cool. I ride this thing to work, brand new. It's only about 3 weeks old. It's already done 400K, so I do about 8,000K a year to get to work, which is quite nice. Keeps me able to eat cheese and drink beer and eat sweets far too much. And then when I'm mucking about, the kids make me do egg and spoon races and things like that at a Victorian village in the Midlands, that is. So normally what you get is a normal GUI developer comes up and goes, I think we need to do some multi-threaded programming. And this would be a good use case. What they actually do is they actually do threaded to programming multi-need. That's kind of what they end up coding. And what they actually meant was multi-threaded programming will look good on my CV. You know, CV-driven development is always a fantastic thing. In general, a developer who's done multi-threading, especially with .NET 2.0 type stuff, they do it once, and then they try never to do it again. Because they got burned. I know I worked on a fixed price contract for a TV company, and I worked for 2 weeks for no money in order to finish my code because I put multi-threading where it shouldn't be and had to strip it all back out. I thought it'd be really useful, but it turned out it was working fast enough as it was. So why do we want to do multi-threading? In the old days, we used to have these all the time. That's a Windows 3.1 hourglass, or Windows NT 3.51 hourglass. And I'm not saying that the hourglass came up a lot, but it came up enough that you could load a different theme into Windows and have animated dinosaurs as your hourglass. Right? No mucking about. And they were really cute, especially the one with the bow. So yeah, they actually disappeared with Windows 7, which was no one mourned their loss, I'm afraid. It was really sad to see them again. But what we want to do in our situation, we don't have the hourglass as much anymore. So I'm assuming you're all creating applications, maybe on the server, maybe in services, maybe in UI. But you've got to analyze what your problem really is. And there's two real good use cases for desiring multi-threading. One of them is you might be I/O constrained, maybe. And one of them is maybe you're CPU constrained. You're doing a lot of work and wanting to do a lot of calculation and computation. So clearly, the prime example of this is making a cup of tea, because I'm from England, I make cups of tea. If you're I/O bound, as an example of that, boiling the kettle. You are just sat there waiting for the kettle to boil. Now, you don't actually sit there waiting for the kettle to boil. You can go around the kitchen, you can make a sandwich, you can get something else ready, you can talk to people, you can go off and watch TV and wait for it to go click, which is kind of the callback that tells you it's finished. That's normally after there's a lot of steam under your cupboard that's kind of gone up the wall and things like that as well. Once it has boiled, of course, if you were doing anything else, you become CPU bound, as you've got 3 or 4 mugs to put tea bags in, fill the water, put the sugar in, put the milk in, and then you're really quite busy. You have enough time to chat to someone who's near you, but you're probably not trying to put tea bags in while making a sandwich with the other hand, because that'd be quite tricky. Because it's one of those circular and straight things that you never get right, and you'll just start spreading your jam like this on the sandwich. So yes, so key point, do analyze what you're trying to do first. and think about what you're trying to do and think about the resources you're going to need. So when we're talking about I/O-bound operations, this is where async await that came in C#5 is really good. Because this is one of its prime design goals, was I/O-bound type operations. It's when you are waiting for something to happen. It might be a network call, you may be writing to a database, you may be fiddling around with files, something like that. And the key point is you can do something useful in the meantime, right? That's a really important concept. We could keep our UI responsive in an application. We could process partial results. We might have put requests out for 200 files, and we're going to convert them from one format to another, and we can start converting them before we've got all 100 on the system. Or we could be issuing new requests. The first file comes in, it needs a thumbnail. We can send off a message to make a thumbnail from this file because we make thumbnails for these types of files, things like that. So it would be more productive. So one of the key ones, and the easiest one to show, was the idea of a Windows Forms application or a WPF application, and when it locks the UI up. So we're going to just load the tiniest little application in the world into VS. There we are. I used to be a VB6 programmer, and I lived my life making grey forms with grey buttons on, I tell you now. And yeah, so this is a very simple form. It just counts cards. All it does is count from 1 to 52, update a label on the form to show you what count card it's on currently, puts a delay in because otherwise it would do it way too fast. And in the meantime, while it's running, you could also eat something or you could drink something, you know, and we can resize the form because it's, you know, it's a Windows form, of course. And we go and count those cards, and I don't see anything. I can't click the buttons anymore, and the form doesn't move. Oh, now it moved, and it updated, but only with the last value, and we've got all the things we clicked on happening at the end. So it's queued up all these requests, but it was so busy, it didn't do anything. So if you were in the old days of VB, you would have shoved a do event and a form.repaint right in the middle of that code to force it to do it all. But it's OK, because we now have a much better way of doing this. We can actually await things happening. So I'm going to await the delay. We're updating the card count. So we're saying we're going to do the same count that we did before, but every time we do a delay, we're going to allow other things to happen while we wait for that delay to happen. So imagine that's a network call or a database call or something else that's I/O bound. So now, when I count the cards, I can still do that, and I can still make my form thing. You can have shared, you can access variables between them, which was really hard in forms to marshal threads and background threads and try and get data between them because it's shared state, and shared state's quite a pain in multi-threading. Of course, you want to make sure in the multi-threaded world, you do have to think a bit about what is allowed to happen while you're doing this awaiting. Say if you press the button repeatedly, like that, you don't really want to do that. So that's where, although you get a quick gain, you do have to think about what the consequences are of allowing things to happen in the meantime. And in order to do all that, all we did was put the keyword, I will make that bigger, that's way too small, is the keyword async at the start of our method, magic fairy dust, and did an await inside. And that was enough for the compiler to create a state engine around my method that would remember what was happening in between, link up a callback, do loads of boilerplate code that you wouldn't want to write, and make your life a lot easier, and make you look really smart as you demo that to a product manager. And everything works in a way that it always used to be quite a pain. So that's a simple async await. You do have to check if you are only I/O bound. So this is a juggling machine that they made in the Czech Republic that manages to get 5 balls being juggled at the same time, which is quite impressive. Probably it gets blocked. At the point where it's juggling about 5, It was I/O bound in that it was waiting for the first, when it was only juggling 2, it was waiting for the balls to come back, and it had enough time to add a 3rd ball. It had enough time to add a 4th ball and a 5th, and then probably about 5, it's going to struggle. Because now the balls are landing at the same time it would be throwing them, and it can't really juggle everything at the same time anymore. This is the kind of thing you'd get in real life. So one of our developers was doing a migration of data. So we're taking data from a database, old SQL Server, we're pushing it into an event stream in an event store, and he tested it all out on local DBs, all works, shoved it on the live DB in production, and one of our machines fell over. He basically decided to push in 100 tasks because he batched the job, so just to make sure it wasn't a complete, single job. Batched into 100 tasks and then did when all on all 100 of them. And the question I asked was, how many CPUs are in that server that you pushed that to? I don't know, is the answer. And he goes, doesn't it throttle for you automatically and know how many CPUs you have and just do the sensible thing? And I goes, no, it does what you told it, which was do all these 100 tasks and wait for them all to finish. And consumed so much CPU, it took every other service out on that box. So this is not a good thing. So this is where you come to a few handy patterns. Unbelievably, this is a white paper from 2012 that Stephen Taub wrote. You need to Google for a document called tap.docx. And I still have to keep pointing people at it and say, please read this, because this is really good and gives you a load of patterns that you will really like. So you can have redundancy. This is a very simple when any type scenario where you can say, hey, I'm going for five share prices, services, get me one of them. As soon as I get one, I'm happy, and I'll just use that and forget about the rest, that kind of thing. So that's the easy kind of one. Interleaving is where you can do things like, I've got a long-running process, and once it's finished, I could do a little bit of work, and I'll put that in between, but keep a load of jobs going in the meantime and limit what the long stuff is. But throttling is by far the one that I see wanting to be used most. So we'll have a demo of that. And these are, you've got to consider, again, now we're in the I/O, even though we've considered I/O versus CPU and tried to balance what we're trying to achieve, we also need to work out which pattern would be suitable for our usage in this case. So as an example, I used to work at a startup that encoded MP3 files. We had an 8-core processor. If you encoded 8 MP3 files all at the same time with FFmpeg in the background, and they're all on different threads, and you use all 8, then at some point, SQL Server decides to stop responding. And you can't actually write any success that you might have managed to write a file out from the MP3 encoding. So that's where we throttled it back to 7. And we did that not with async await, but by having services that ran as Windows services that could only do one thread at a time, and that throttled it back, but we could have multiple Windows services, which gives you, by the way, a very cheap way of doing multi-threading in the old style. So looking at those patterns, we can go to another sample piece of code. It's another classic piece of design, I'll tell you now. But fortunately for you, I managed to put a graphic on it. So it's got an image, see, lovely image. But it still is a grey box and stuff. So this is basically coming from that world of MP3 encoding. So there's a band in Sheffield who have tracks on Bandcamp. So I decided, what if we downloaded the OGG file, the FLAC file, the AAC, the MP3, and we just copy the files. So I wanted something asynchronous that I could demo at a conference where I wasn't relying on a network being available. Because that's the problem with async. A lot of people use it with web services as a demo, and unfortunately, not all conference Wi-Fis are equal. And not every conference can allow my 3G little dongles to work. So I decided on files. So we have a very simple interface. It's got a source directory, which is here. So get the window key properly. There we are. So it's going to take files from this folder over here, and it's going to put them into a temporary folder, which is the default Windows temporary folder for my user. So if we go and run it up, I'm going to have a look in that folder. just to show you what's in there. So we just have a load of files. We've got MP3 files, we've got FLAC. Clearly, the reason I kind of did this is because the FLAC files are bigger and take longer to copy than the MP3s and the AACs. So you can see how the files copy much faster than one or the other. Even when it's on an SSD, it takes time to copy bits around. So the simple way of doing it, I will copy this code sample straight in, and then we'll have a look at it. Get to the button. When all click, there you are. You can see that I do most of my coding on server side nowadays. So there we are. And oh, I did do the code because I tested it to make sure it worked. So let's just paste it in to make sure. So what have we got? We've got. Yeah. Let's not run it in debug mode. Let's show you the code first. Come on, full screen. View, full screen. Oh, Shift Alt Enter, there we are. So all we're doing is getting a list of all the file names to copy. So we're going to go off. We're going to get a list of all the files that are in a folder. We're doing it where we actually iterate through all the subfolders as well. We're then going to do a copy file async. So this is quite important. If you use the standard copy file, we'll get no benefit of this. We do have to do things like use async methods. Using an async method means we don't just copy a file, we actually do streams. So we copy async bytes in streams. So it's not quite as easy as just file copy. We have to go and process a stream, but that's not a bad thing. That's kind of what you'd expect. And then we just do an await on this. And we do the really important when all, copy the tasks. And then play the first file we get. Now there is a temp folder here. That we can look at, and we can see all these files come in. So when I do the click, we should see these files start to come in. There we are. In they come as little temp files, and then they finally get their proper file names coming in. And you can see how the OGG files take slightly longer and FLAC because they're bigger files. And then eventually it gets through and plays the music. Your mileage may vary on whether you like an indie guitar band from Sheffield. I think they're pretty good, but there you are. I'm a typical indie kid. So yeah, so we have a load of files copied. So that was really nice because we just said, hey, here's a load of stuff to do. Wait till they're all finished. And it went off and did them all, and it did them all as fast as it could, and it did it asynchronously. While it was doing it, I can probably move the form around a bit, maybe, yes. So I can still move the form around. I still had a bit of responsiveness, not great. I didn't put much pauses in there, but it didn't go completely dead while it was doing it, so that's fine. So we got some of the lovely benefits of asynciness, but that's the most basic thing. That's the, hey, let's do everything in the world. Whereas what we can do, and I talked about throttling, and this is the much more interesting one. This is where I was saying to that guy at work, what you should have done was do throttling. Here's the white paper, let's go and write it, and make sure we have that in a way we can reuse. And it's relatively easy to do. So anyone who's not used to async, I'm hoping some people have seen async before, because I glibly ran over what when all did really, is you get a group of tasks. We can put them into these combinator functions, when all, when any. When all is the process every task going, and the when any is, I'm going to give you a load of work. When any of them's finished, come back to me. So that was when I said we could be looking for a share price or a weather or a coordinate, GPS coordinate lookup. And you don't care, probably the first one's good enough. You just went to multiple services just to make sure you had redundancy. But the other thing we can use when any for is when we finish doing one, we can then do something else. We could do a bit of processing. But one of the things we could do is we can actually throttle how much work we're doing at any one time. So we can actually say our list of copies should only ever have 4 in at any one time. So we can say, hey, I'm going to put 4 things into this list, and I'm going to wait for one of them to get processed. So first of all, we fill our little array with the first 4 copy files that we're going to have, our list. And then we're going to say, if we've still got stuff to do, we're going to go round. We're going to, if we find, we're going to wait for any of them to finish. When we get back the task that's finished, we say, so if you've finished, we can get you out of that list of tasks that we're doing. And if we've still got things to do, I can add a new one into that list. So I had 4, 1 finished. I now have 3. I remove it, I put another one in, and then I run it again and keep going until I eventually get no tasks left. The really good bit is you might say, but what if when any runs and all of them have finished? Well, you just get the first one back out. And if you then called it again, you get the next one out that had finished. Possibly in order. I'm not sure how deterministic it is on how it hands them back. It doesn't really matter because you didn't care enough because you put when any anyway, so who cared what order they finished in. But you eventually drain the queue of work. So this little bit of boilerplate, normally if you've got really intensive stuff, you might have concurrent things being maybe the level of your CPUs. Maybe it's about 2 times the CPU, because maybe it's mostly I/O, but it's using 5% of CPU. But of course, 5% of CPU over that 100 tasks that my dev put in is more than 100%. That's why the server didn't like it. So by doing this, he could easily rack it back to 10, 20, whatever it was, scale it depending on the dev system, a staging system, a live system. And if we do this, we can see it in action. So if I get that little window up that shows me the files I'm copying, then when we do this, we get 4 files at a time. So it does 4 files. As soon as there's a temp file finished, disappears, another temp file appears, and it gradually just keeps going through. And probably my form is more responsive. Look. Responsive enough, it does that silly thing in Windows where it minimizes everything if you drag it around. So let's see if it comes back. No, thank you. So yeah, so that's throttling. And that's a really simple pattern that's in that white paper by Stephen Taub. So I guarantee that if you haven't read that white paper by Stephen Taub and you use async await, then you should go off and read that white paper by Stephen Taub. It's only about 12 pages of your life. It's less time than you spent on Pokemon yesterday. And your code will be much better for it. So that's just a really quick example of how async await can be made much better and much more suitable for production systems. I did get asked by a developer, but surely they should have just given us that in the library. And I'm glad that what we have now is a sensible framework which does not overload every method, does not have every variation you may want, but can give you, in these 10 lines of code, you can easily get it down to quite a simple structure. I'm sure if I didn't do for each and did lambdas and a bit fancier stuff, it'd be less code on the screen. And there's anyone do F#? Because they'd be going, you don't even need, it's 2 lines, it's just filtered, yeah. But, you know, that's just, F#'s really good at doing pipelines, it has to be said. So what are the gotchas that I think exist in the async await world? Well, one of them is, please, 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 always return a task of some type from your async methods, right? It's really rude to not return anything and just return void. If you return void, which basically is only in there for things like UI handlers on Windows Forms, and if they hadn't had to deal with that, they'd have never allowed it to be put in the system in the first place. What you give by returning this task is you allow someone calling you to work out what your state is, to work out if you had exceptions. All sorts of things that are handy and useful can be done. If you haven't done async await, I kind of assume, who has done async await in here? Ooh, good. You all know what task T is. Task T means that it will return whatever type you have, effectively. So a method that would have returned int, you would convert into a type of task int. And then when you do things like when any, it can return you back one value, which is int, and it does all the work for you to kind of give you the generic value, and you can get the task if you want. So it's really cool how they've templated this stuff. You also get cancellation in an async await. Now, this is something that existed in the TPL anyway. It's a really cool thing. You create a cancellation token. You hand it to anything that's part of what you would consider a process that exists as kind of a bounded context or transaction. And if something goes wrong, one of you can go, hey, cancel this, and immediately it will start cancelling throughout the whole system for anyone listening to that cancellation token and handling it properly. Now, the interesting one was when I first showed someone cancellation, they put a cancellation token into the first async method, didn't hand it to any of the calls underneath, and then said, it doesn't cancel anything underneath. I went, well, you haven't told it to. I said, but it should magically know how to kill all my work, my threads underneath. And I said, well, does it magically know which files to remove? Which database transactions to roll back? All that kind of thing? Because the only guy who really knows that is the person who's coding it. That's the only person who can properly guess what should be rolled back with a cancellation. So I think cancellation tokens are really good. It's a really good pattern for cancelling multiple things all over the place and used throughout the TPL, and we'll see it later in Dataflow. Yeah, got the Australian pronunciation. I will say Dataflow occasionally. They are really useful. You do have to handle them. They do throw exceptions, and some people don't like exceptions, even though they're a useful thing to have in the system. So cancellation tokens are really cool as well. They're not magic, though. They do have to be dealt with. And exceptions, async methods kind of don't throw exceptions like you think they do. So we'll do an example of that as well, because that's a bit of a nightmare. The other thing is, and someone actually tweeted me and said, can you tell developers not to use the word async at the end of their async methods? I don't know whether he was trolling me. Seriously believes you shouldn't put async at the end of async methods. One of the things you shouldn't do is call a method async and don't have the async modifier on it, because that's a really bad idea, right? Which is why we had a problem with exceptions in a piece of open source code. Someone submitted a load of mocks and didn't put the async keyword in, but left the async at the end of a method, because they were auto-generated. And that caused a bit of a nightmare in the testing. So I think first we'll look at cancellation, because I think cancellation is quite cool.
Look, you're going to need it.
They are. There are some Star Wars sound effects randomly put through this presentation, based on the title of the presentation. And that was good luck, you're going to need it, which quite often in the async world is how you feel at first. So we want the ability to do cancellation. Now, this will be tricky. There we are. So we have the ability to do cancellation. And this is in the when any first wins. So the time when you want this is in that case where I'm going to say, hey, I'm going to happily take whatever the first result is. But if you do that, and you are going to work like that, what you're then saying is, and I need this one. Yeah. What you're saying is that when I cancel, I really ought to be rolling something back as well. There's no way that I should just cancel something. So I'm copying files. Clearly, if I'm going to copy files, I really don't want to have the situation. Let's see if that works, see if that compiles. I don't want the situation where I cancel the file copies because I've got the first version I want, but leave all the remaining partially filled files on the file system. That's a bad idea. So what we need to do in that case, is we've added an extra parameter called cancellation token into our copy files async. And one of the things it does is it spots if it gets an operation cancelled exception. And if it does, it will delete the temporary file it's been copying at the time. And that's it. that's the ability for us to cancel all operations. So I don't have to go around every task, because this is the nightmare. You've got 100 file copies, you've handed them all over, you can't put a cancel through. Do I have to iterate through every file copy telling it to stop? And the answer is no. You handed them all the same token, and you can cancel them all like that. So that's why cancellation token's so much nicer. And all we're doing is sending these copy files with one single token. And all we do is create a cancellation token source that's going to cancel all these and give the token in from that to all our methods. So hopefully, when any first wins comes in, we should be able to see the files come in. So it copies a few. Oh. Ooh. I think that's me not having Ogg Vorbis support on my laptop. Whoops. But basically, it managed to copy the one file it needed and then has deleted all the temp files. I'll just show you that again because that was an error that didn't really matter. That was just an audio support format not being supported. So yeah, so we get that one file and we've cancelled everything down. And that can be really important because some of these things, cost money. So when you're going out to services and you're asking for information and you're saying, hey, we need this information, if you don't cancel them down, you'll be charged for that work.
Or do not.
Yes?
There is no try.
It will matter if two tasks both complete at the same time.
Yep.
When any returns one of them, but because they both completed, you will end up with two completed files because there's nothing left to cancel.
Interestingly, if I run that enough, that's exactly what happens. Because the MP3 format file, oh no, the WMA and the AAC files are so close to the same file size that about 1 in 10 times you will get both files. And there's virtually nothing you can do about that. So, so good catch. That does happen if I run the demo often enough. But I can imagine someone getting really upset about that and saying, but this is just unusable. We can't possibly have this happen. And you're kind of going, well, what you're saying is we've copied everything bar, if it had 1 byte less, we would have been okay with it, but now it has 2 bytes, we really get upset. So again, this is like that button on that original form, which if you click multiple times, gives you random results. You have to be aware that things can happen. You can get 2 completed things even though you really only wanted 1. So probably you want to play the first thing in that directory, and maybe you have a cleanup if you wanted. We'll clean up anything that seems to be extraneous in that folder. So those kind of considerations have to be done. If you're going to do multiple things at the same time, you have to cope with the fact that multiple things get done at the same time. It's one of those things. Sounds obvious. So let's go. Because I want it to be cool, obviously, I've written something in .NET Core, which is always a brave thing to do. To be honest, I battled it for about an hour before someone said, you didn't do .NET Fetch. Of course it wouldn't work. It's a random bit of syntax that I didn't know about. So what we've got is a very simple console write line. So what we're going to deal with is how you get exceptions in the async world. And this is what caught someone out in the Brighter open source project that Ian Cooper, my boss at Huddle, has created. And someone did a submit and they put in a load of tests, and the tests were mocks, so they just threw exceptions in order to say, hey, we're not implemented. And it never got to the unit test we really wanted it to get to, which was a when all, because it couldn't get to it because all these exceptions got thrown immediately and never made it to the loop that was going to do the when all, the bit of code that was responsible for that. So we were struggling it, and we spent about half a day trying to work out why on earth these tasks seemed to get executed ahead of time and weren't captured by the when all. And then we realized no one had put the async modifier on the method. They had called it async, and there was a moment where you're the guy who's meant to know about async. How come you didn't know that? And goes, well, if you do put the word async at the end of your method name, I will assume it can be awaited and its async type modifier is on it. So let's have a look. All we're going to do is trivially add one number to another number, unless it's do something, and then we always return 42, because that's obviously the ultimate answer that you can ever have. And so it's really boring bit of code. So we'll just run it. .NET Run compiles and runs it, but it was already compiled, so it's OK. So we say, yeah, that's a non-async, and we get 42. Can anyone read that, or is it tiny? Fine. OK, go with that. So yeah, so that's as you'd expect. So you can start putting exceptions in. So you go, right, so if I did have an exception in my console main method, so that's the entry method for the console app, what would we expect to happen? Because it's .NET Core, so just so you know. Oops. What did I do wrong? That didn't compile, did it? Oh, good. Please compile. Where's the rest? Oh. Yeah, there's me, fat fingers on the keyboard. I bet you I didn't save it properly either. That's better. There you are. So that's an exception coming out of your console, which is the kind of thing you expect. You know, we've got an exception. It's in main. So that's fine. That's exactly how I'd expect an exception to work, so that's fine. So what if we threw an exception? We've got do something here that's not asynchronous, so let's see what happens there. So that's a simple thing. And what we get to is we're trying to do something asynchronous, but yeah, we got an exception. Will not be async, 42 didn't complete. We didn't get any further either. We didn't carry on doing the asynchronous functions either, because we just stopped dead. And we got an exception thrown. It's fine, we would have handled that. So what we're going to do is in the async method, so really important, this is an async method. Not just because it's got async at the end, but it has the async modifier on. I cannot emphasize that too much. Until you've seen a seasoned architect, coder, C# MVP swearing at a machine for a day, just because of this, you'll realize how painful it was. So this has got an exception being thrown in async. Nothing. Right? Nothing came out of that. Right? So that's the expected behavior for an async method. It should not be throwing exceptions as an exception stack. Well, it is the designed behavior for how it works. Let's put it that way. So it says it will be async, but it never got to the point where it actually was async. Now, this is where, if you start doing things like, well, what I could do, remember I said you should return tasks from methods? Because I've actually returned a task, I can actually, and I have a reference to it, I can actually go and see if there was an exception when I ran it. So now I can go, right, was there an exception when I ran that? And the answer is yes. I have a stack trace. So I actually knew there was an exception when I was running that piece of code. And I can see it. It didn't throw an exception like I'd kind of expect in the same way. It was a system aggregate exception, because with the TPL, you're doing multiple things at once, and if you get exceptions, you kind of want to roll them into a big bag and hand them back going, hey, there was a lot of stuff that didn't work at this point. And that's the key bit, because if we actually go back one, if we'd have actually done a when all, or wait all, in this case, so we're waiting for everything to be finished, then we do get an exception. So this is where those task when all wait all actually do throw real exceptions for you to catch like you'd expect. So that's how you really are meant, it's when you've got to a point where this aggregate exception makes sense to hand back to you, because you are at the point where you want to know all the errors that would have happened in your async methods. The interesting bit is, and the final bit I will throw in, is that I can actually make my test some ideas an async method. And if I do that, and do a quick run. So all I did was put the async modifier on and change the method name because we should do. I've now buried that exception again. It's disappeared again. So you've got to be really careful with what you're doing with exceptions. If you're going to await stuff, really check the tasks coming back and check things that are handed back and make sure that you're getting the thing that you expected. Yes?
What's your view on exceptions from precondition failures?
Or do not.
Eager versus.
There is no try.
Sorry.
Want me to explain what I mean?
You can, yes.
So,
Go for it.
if I'm feeling particularly good and want to have an async method that only accepts non-null references, because that's a programming failure rather than a system is in the wrong kind of state
Yeah.
failure, I would normally have a method that ends with async but doesn't have the async modifier that validates the parameters and then just returns by calling a real async method so that you get the exception eagerly.
Aha.
Which kind of gives a nicer result, I think.
So for the people who obviously won't hear that on the video, with a helpful comment from John Skeet there. The suggestion there was, you often in methods, you would do pre-checks on the variables coming into the method and certain states that would cause fast failure, is what I would call it, where you know you're not going to be able to run anything. So this is a tactic where you actually do have async, a method with async at the end, which actually doesn't have an async modifier, so that you immediately do a load of checks for preconditions on parameters are correct or the state of the system's correct that it could do the work. And then underneath that, it actually does the call to an async method. That way, you get a very early exception fast failure instead of burying them all till the end, and then you suddenly find out in an aggregate world that you've got a failure. So that's a different pattern that you can implement, which is quite a nice one, but does have an async method which feels like it isn't async. There's always one exception. Yes. So we've covered I/O bound, and I'm probably going to run out of time to cover the full data flow. But we also have CPU bound. So there is a very easy method, async await. It's the easy way of trying to get I/O bound asynchronous operation, that kind of multi-threaded. Although it's really a single thread and it's kind of a fancy do events in my head. But it's more than that. But yes, so how would you do true CPU multi-threading in an easy way that your life is very easy to do this? Well, one of the things that was out even before async await was TPL data flow, or data flow. And it was available as a NuGet package. Because it's available as a NuGet package, no one knows about it, because it's not built into the framework. And if it doesn't exist in the actual framework, it's kind of hidden away in something you have to download. And I doubt in 2011 everyone was keen on NuGet, in the same way they're really keen on it now. You're all keen on NuGet, aren't you? You never have any problems. And so this is now built into the .NET Core libraries. I actually genuinely was trying a .NET Core version of what we're going to see. I was trying to find the package that Dataflow would be in, and it wasn't there because it's there all the time in the .NET Core library, because it isn't a big thing, actually. So this is kind of an actor-based pattern. It's an in-process actor-based pattern. If you have Orleans or Akka, you can spread it across servers, but this is kind of an explicitly in-process. You can explicitly say how many threads you're meant to be processing using at any one time to do work. It builds in queuing of inputs and outputs, so we can send a load of jobs out like this, and it will queue them automatically, doing the throttling for you, so you don't have to worry about that kind of throttling pattern type situation. And it supports all the things like task cancellations and things like that. What you should search for is tpl-dataflow.docx, which appears to be written by Stephen Taub again. Yes, there you are. And that's still worth reading to see how it works and what the initial goals of that was. Now, the actor pattern, I won't go into big depth about the actor pattern, but 1973 was the first white papers on the actor pattern. I was 4 at that point. That's, frightening. This was created by physicists who had really big systems and wanted to work out how to, the weather. Let's say They were trying to work out how the weather worked, not how a nuclear bomb exploded. The weather. But it maps really well onto our multi-core architectures we have now, and especially distributed as well. But it's, for us, multi-core in process. And one of the biggest things you're ever going to have in multi-threading is shared state. You have things that you shove on thread storage, and all sorts of nasty things to hack around the fact that you've got multiple threads, or you locking variables that you then unlock when you're finished with them, and things like that. And that causes real bottlenecks. So this isn't a good thing. So they came up with the idea of this actor model. So instead of your program being a kind of really direct sequence of states that built on top of what was done before and what was done before, and they could access everything that had ever happened, you send messages between little actors. And an actor it's like a little black box. You send some stuff to it, it processes it internally, doesn't access anything that another little block would access. Maybe it writes to a database, which is kind of shared state, but you know, at some point you have to save something somewhere, maybe every now and then, in a database, if you want to keep it around, which means don't use Mongo. And eventually it spits out another message into another bit that can handle it. So it's like joining little Lego blocks together. And as soon as you don't share global state and you don't have this horrible state model, your testing is easier. Unbelievably, all your testing becomes much easier. Everything's more predictable and everything's easier to scale. So we avoid all that shared state. We're just doing inputs and outputs into these little blocks. We don't have lock statements. We haven't got thread states. And we only transmit things via messages. And you can't broadcast a message to everyone because there's no everyone, because that would be shared state to have a list of who everyone is. So that would be a bad move as well. And all this ends up with the guys in the TPL adding to the TPL library this data flow library. So we have targets and propagators, and we can do filtering and connect blocks together. So you kind of get, it's almost like going back to a software version of a like little breadboard with circuits, and you can go and join all the wires together. And it's really cool. So what I'm going to show you is the basic, really basic one of the action block, and show how easy it could be to add multi-threading into your VB or your app. VB app, God. Into your app really easily. I wrote some really good stuff in VB6 towards the end. All these projects are available on GitHub, and I'll give you the GitHub address at the end. And also, there's full 1-hour videos of just TPL data flow, and there's just the patterns and practices, and they're available on NDC's Vimeo sites, so you can have a look at the presentation, get my stats up, and make it look more popular than it really is. So all we're going to do here is, if anyone's heard of, people over here, you heard that BBC have something called iPlayer, which allows you to do video on demand. ABC have got their own system, and someone did a talk on it about how they've implemented it. BBC implemented it fairly simply, and it's all based on Flash, and they haven't really done DRM, which means that if you've paid your TV license, you may feel justified in downloading a lot of series of The Clangers or Doctor Who or whatever it happens to be. And they're really handy for creating an MD5 checksum, because it takes quite a bit of time to do an MD5 checksum. So we have a CPU-intensive operation. It's kind of IO-intensive because you've got to read huge files off the file system, but the real work is the MD5 calculation, because you have to read every byte to get to the end, just in order to work out what the MD5 is. So that's what we're basing our data set on. We've gone from music files, and we're now into this concept of video files that we're going to do an MD5 check on. So let's do one without data flow. That would be a better one. So this is a console app. You'll be glad to know that my design skills have been thrown away. And it's in process folder. Oh no, you just paste the whole lot. That's it. So what we have in here is a very simple thing, something that can write an MD5 file to the file system. So that's really dull. Something that can calculate an MD5, which is in the is it the security libraries? Something libraries. Some library in .NET can do it. Let me just say cryptography libraries. That's the word I was looking for. Cryptography, because nothing is better than MD5 for... Yes, don't even start me on that. These passwords just went out with MD5 hashes all over them, and it's really easy to reverse them. Is it Disney? Just went and screwed up. One of the sites has just done it, really big time. So all we're going to do is process every file in a folder, and we're going to get the file path, and then we're going to print out what the MD5 for that file path is. So if I run that, you end up with a console app that just goes through, clangers, one file, does it once. This is not asynchronous, so there's no multi-threading in this. We're just doing a simple thing of I'm going to create the MD5 for every file in this directory. So that's, you know, it does its job, but clearly we could have made this multi-threaded. And we really want to do it to be multi-threaded. So let's see what the TPL data flow can give us. Now I'm going to just do one thing and cut a line out. So don't look, close your eyes. It's like the football footy results. Look away now from this bit because I haven't got 2 code snippets because I'm too lazy. So what we're going to do is we had that piece of work that went through a folder and it went through the files and it calculated the MD5. So what we've done is we've moved the bit that was in here, we've moved out to its own method, display MD5 from file on console. We've moved it out, and because of that, we can now create this new thing from the Dataflow library called action block. And we hand it a string, which is the file path, and it will call that method with that file path and do exactly the same thing we did before and puts it on the console. What we actually do, though, is we get the files from the folder and we post them into that block. So we're not iterating through every file. This finishes really fast. Because remember I said these blocks have their internal queues, so they can take data just stuffed in them and will automatically queue them all up for you. So we post all this. So if we want to make sure everything's got done, we say, hey, we've completed all our work. Don't accept any more messages into that block. And then I'm going to wait for it to finish. So we do all that work. We've added about 10 lines of code. And we're still only doing kind of one at a time. It was faster. You see how this was much faster? That's nothing to do with Dataflow. That's called NTFS file caching. Right? Just a warning. That's what really made the difference at the start. There's 16 gig of RAM in this machine, and NTFS grabs about 3 gig of it to cache every file it can out of existence. So, but what we can do, now we've got this action block and this structure of doing tasks as messages, we can actually configure the action block. And we can say, please use 4 threads when you're processing these files. That's it. All we had to do was say to this action block, use 4 threads. Go ahead, use 4 threads. I didn't have to think about thread pools. I didn't get new threads. I didn't create them. I didn't have to think about where they came from, how we would reuse them, all that kind of thing. And bang, it's now doing 4 at a time. So I've now got a 400% increase in my productivity of creating MD5s from BBC iPlayer downloads. And it's a really quick win, because there was very little refactoring to do. We took that console, the kind of work that was being done into a method, shoved that into an action block, and then told the action block, go ahead, make this multi-threaded. How many people are using the Dataflow library? How many people have never heard of it? Yeah. How many people wish they'd heard of it? Yeah, you see. A bit odd, isn't it? So this is what it is. You post stuff into it. It gets queued. It does work. And you can put the word 4 on the top, and it will do it in 4. You know, that's indicating 4 CPUs. One of the other things you have is transform block. So I'm going to rush a bit through this because we're getting near the end. But seriously, the presentation on NDC is pretty well recorded because it was done in Oslo. So have a look at that and look through the code on GitHub. But this is where you put in a file path, and then it outputs a file path and the MD5 information for that file path. This is where you can isolate this bit is doing the real work, and then this bit is doing a bit of UI work. So the real work that's CPU intensive, we want to go across 4 threads. The thing that writes to a console doesn't need to be multi-threaded. We'll pump that into a single thread. So this is where you kind of try and work out where the bits that are bottlenecks, we'll split those up. And the bits that aren't bottlenecks, don't try and use multiple threads to do something like writing to a console because it's not required. And you can do really fancy stuff. So one of the things we can do is we can have something called transform many block. That takes many things in, pumps many things out. More importantly, I could have left, by the way, a transform block with 4 threads, or you can split it out and fan out like this if you want it to be more explicit. But we can actually start putting filters on these blocks. So you can just say, hey, every time you get a message, run this bit of code, and if this returns true, then connect this message to the next block. So it says, hey, I'm getting messages. I'm going to hand them over to here and transform them and then send them on to something. And we can make that if it's a file, I go off and create MD5s. If it's a folder, a directory, we go back into here and get the files again. This is recursive programming, multi-threaded, made easy. Right. Seriously, much easier than trying to do it by hand. And then we go and link all those transform blocks can feed back into the action block that sends everything to a console. So to give you a feel for what that code looks like, very quickly, because I claimed it was really easy. And it's really naughty to say, it's really easy, and I'm not going to show you the code. That's a bit bad of me. By the way, I find it is quite important, if you're going to do something fancy in Dataflow, is to draw the diagram of how everything joins up, and don't try and code it, because I think that's quite a hard way to start it. So we have folder contents block. This is the first thing in that diagram that was on the left. And we say, we're going to link the output of this to the folder contents block every time we find it's a folder and not a file. So anything else, down here, there, if we get a folder contents block, we link that to a create MD5 block if we find a file. So we're wiring them all together, and that's the wiring. Just very simple, link to where it's going to go to and a predicate that returns true or false. And that way we can have meshes and joins and send things out really nicely. And that's it. That's enough to make it recursive. If you're unlucky, you've managed to get one of those special folders in NTFS that links to itself, and you'll never end. But, you know, hopefully it's not one of those. It shouldn't be. They're really evil. They should not be allowed. But it's OK now, because you won't fail quickly on that, because we've now got rid of MaxPath. So we'll just carry on forever, whereas we used to crash really fast on those kind of folders. So just as a summary of what you get with Dataflow, is you get an action block where it just does something but doesn't pass the message on. You get these transform blocks that take in a message, does something to it, changes its shape, maybe, and spits it back out. Buffers that just buffer up a load of messages so that you can just sync them all out into one place and then fan them out. We can do batches of inputs, so we know we're only ever going to start processing when we get 5 things, so that we can actually schedule batches of work. We can broadcast to or loads of blocks at the end. So that's really handy if you say, I finished creating this file, I finished encoding it, I'm going to send it to an orthogonal responsibility, which is a logger that just logs that we actually encoded something. I'm going to record into SQL that we encoded it over here, and I'm going to move the file onto this place, which is a dispatch area where we can actually start thinking about selling this file on a music download site. So that's how you can send off multiple things at once. And obviously, the orthogonal things like logging to a file are less important, so that they can be on a lower priority and less threads. So general concurrency issues which we get is shared state. That's why we have concurrent collections, which is really good because you can access them from multiple threads. I would say be careful with singletons. There's a reason singleton is the pattern that most people know the most. and is the anti-pattern that most people know the most. And it's evil, and it can be nice. It's really hard to distinguish the two, and it's a fine line, and happens quite a lot. Beware of locking conditions. Anyone had SQL deadlocks, where someone's got a transaction? You get the same stuff in multi-threaded code if you're not careful. This is why it's really handy to have wrappers like the Dataflow and async await. Dataflow forces you to not lock things and share state. By doing that, you avoid these kind of things. There are useful NuGet packages such as Poly, if anyone's used it, a policy engine. That's really good for doing retries and backing off. So if you do get a lock, you can back off and then come back in later. And compensating actions. You have not got the ability to just go rollback. Hopefully you don't want to use MSDTC for distributed transactions across multiple servers. Please don't. It will stop working when you go to a modern version of SQL Server because it really doesn't like that for all its read-only replica stuff. It hates multiple distributed transactions. So you need to think about what it means for you to fail and what you would do if you did fail. And is there anything you can compensate? Or do you just send a message to your DevOps email address for that team and tell them to sort the mess out that's just happened? You know, which is actually a valid thing to do. Is human beings are much better at resolving inconsistencies than your best guess at the time that you couldn't work out what necessarily went wrong. But we've coded for it, because you can't code for everything. And the other thing is, it's important to understand how your code is actually running. Is it really multi-threaded? Or is there just a load of CPUs sat at the side, watching this one guy bust his backside off, getting quite hot, because he starts getting quite hot, because you really don't want to get to the point where your server kind of does that. Right? But the meme currently is that's JavaScript, or Node. But I couldn't possibly say that. I'm using this in the, I've seen code like when people do mocks, and what they've done is mock everything out, and there's nothing real ever being tested anymore. We're using threads, but actually everything's on one thread, and no one's really realized is also reasonably common. So yes, if you want to find out, get all the source code for the actor patterns and Dataflow, and for the patterns and practices, they're available on github.com/WesleyL. You can also search for Vimeo NDC Liam Wesley, and if you do that, you will find full 1-hour presentations on the actor's life for me, and also async C# 5.0 patterns for real-world use. I didn't load it. I didn't misspell the word patterns. So whatever you do, don't search for patterns because you won't find it. It's patters, which does sound like an Aussie cricketer. Yeah, patters just went out of crease. But there you are. That's a terrible accent, I'll tell you now. And I'm going to have to handle questions offline because I've really gone over by about 3 minutes. But I'm welcome for anyone to come up and ask questions. And I hope you enjoyed that and it's useful. Cool. And Joe's going to be doing, which room are you in, Joe? Room 1. Room 1 will be advanced async topics, which will be well